dear guests, Professor Ercan Alp, where do I see you? Anyway, guests and honorable chairs of the various sessions today and in the next few days, dear guests from abroad and from the island, thank you very much for being here. And I'm, as a German, tempted to say good evening. In a Greek culture, I would probably say good afternoon. So somewhere in between, we are here, and I'm very happy to see you that we are now back in our intended conference place. So thanks also to the technical colleagues at the Cypress Institute to re-establish this room in a rather quick turnaround, which is much appreciated and reminds me of Britain, but we are here in Cyprus. So it's my great honor tonight to introduce the public keynote lecture by Professor Sturt Manning. Professor Manning is the Goldwin Smith Professor of Classical Archaeology and the director of the Cornell Tree Ring Laboratory. Cornell in the US, I just checked, there's -4 degrees centigrade and snow showers. So I'm sure you're happy to be here, even though we make you work for it. Now, Sturt has been a very staunch and reliable and strong critical friend of not only STAR-C, the Science and Technology in Archaeology and Culture Research Center, but also of the Cypress Institute in advising the leadership of the Cypress Institute how to improve what STAR-C tries to do, in giving directions, in giving constructive feedback. But it's not in that capacity that we are happy to have you here, but in your capacity as an academic with a strong research interest in Aegean, Mediterranean, prehistory, history, classical studies, more recently working on Byzantine material, but not just as an archaeologist, but also in particular with a strong interest in absolute dating. Now, it's always convenient to say late Roman or early Bronze Age. But early Bronze Age in Germany is quite different from the early Bronze Age in, say, Lebanon or Australia, where you're from. Is there an early Bronze Age? No. Okay, so it doesn't even exist. But that highlights one of the questions. How do these different periods relate to each other? Because only through that we can start to explore and understand how culture has spread, how human thought, how human understanding has developed and evolved over time. Absolute dating is a crucial element here to see who is teacher, who is student, who came first, who has developed something independently at the same time. It happens as well. Things are just in the air. So through your work on radiocarbon dating, on dendrochronology in particular, you are making a very significant contribution to the profession as such. Straddling, again, that bridge between the sciences and the humanities that I mentioned earlier today. And in that context, I think it's really fitting that we have you tonight as a keynote speaker here to give us a talk on time, history, and climate in Cyprus, and to brief us on the Cyprus Dendrochronology Laboratory that was recently established as a collaboration between the Department of Antiquities and the Department of Forestry of the Republic of Cyprus and Cornell University and us here at the Cypress Institute. Sturt, please give us a pleasure of your talk.
Well, thank you all very much for coming, and I understand bearing with infrastructure crises, flooding, and many other challenges, so very successful. So it's a great pleasure to be here and to talk about our brand new, there is now a sign on a door actually in one of the other buildings that many of you will not have been in, which actually reads Cyprus Dendrochronology Laboratory, so talking about a real thing. So some pictures on screen to give you an idea, and I don't know whether somebody wants to lower the lights slightly, maybe to see them better. Okay. Many of you hopefully know roughly what dendrochronology is and involves, but I thought I would waste 30 seconds just with an instant primer. The concept is that you find living trees, and if you're standing, and of course I couldn't resist one, in the snow on Dros Mountains, this is a few years ago, and you core a tree, you know when the tree was growing because you're there at a certain date, and the bark is of that year. And then you progressively work back from that into the distant past. And that's what the one on this slide is showing. Living trees, working back through historical buildings, archaeological or paleo-environmental sites. And if you can overlap the ring patterns of the same species in the same area, you can go back and back and back. And if you're, for example, working in southern Germany, and particularly taking advantage of waterlogged wood there, you can go back 12, 14,000 years. If you're working in New Zealand with kauri trees, there's the potential in the future of maybe getting back even 50 or 60,000 years. Many parts of the world, rather less than that, a few hundred or just a few thousand years. Dendrochronology is also a new field. The graph at the bottom left is showing the publications in dendrochronology from the beginning of the field, or at least the modern field. Leonardo da Vinci is not included, nor Aristotle. To the right-hand side, a bit after 2000, and what you'll see is it went from being a non-existent field until very recently. It's only really half a century old, and it's really only in the last few decades it's taken off as a dramatic new thing. So, for example, Rembrandt painted many of his works on oak panels, but it wasn't until the 1960s, and actually really mainly in the 1970s and 80s, people realized you could date those panels, and that was going to be a way of establishing whether you were dealing with a correct and true Rembrandt that he would have been alive to paint, and to actually source it. So when you find a work that is signed but thought to be not so good, but it's painted on wood from the very same tree as a recognized Rembrandt in the Krakow Museum in Poland, you start to think, well, actually the other one must have been in his workshop. It's the same timber, and perhaps it becomes one of those student paints but the master signs, but it becomes a circle of Rembrandt versus being a question mark. So it's been used in many ways like this, but all within the last several decades. And you stretch all of these things together to build up a long time frame. So starting with your modern tree, your historical building, your archaeological site, you're matching together, the idea is you're looking at ring patterns here, the sequences of rings which equal tree growth. Tree growth is controlled by climate, particularly in environment. So trees of the same species, growing in the same area, are going to, broadly speaking, have the same ring pattern. Not identical, but similar. Just as with any population you can think of, everybody does things differently, but if you see a photo showing a group of school students, your brain immediately goes, school students. And if you see a photo of some other group, you go, other group, and you could find them. Trees are the same. They're similar, not identical, and it's the matching those patterns of similarity together that give us our long records. It only works if you have significant overlaps, of course. So typically you're looking for tree ring records that overlap by 50, 100, 200 years to feel really secure you're putting them together soundly. What type of samples do you get? Just a quick set of different things. They range obviously from forest samples, so like whole sections of trees, through to drilling with a special hollow drill to get little cores like the ones in the middle, through using digital techniques that we've been actually pioneering here in Cyprus, and we'll be writing up using a little portable scanner, through coring trees. So it's a 5mm core bit in a huge tree, so it's like a hypodermic syringe in terms of humans. All of these equal samples, or like here, these are waterlogged samples coming from wells in Germany in the case of these two. So all sorts of different circumstances can preserve wood, and then you're studying that wood. The main species of tree on Cyprus that we've worked with so far are shown on the screen. They will be very familiar to many of you who've been into the Drought. That, of course, involves not just driving up the road. As I watched on Sunday, everybody in Cyprus appears to drive to Drought, and then they turn around and drive back. If you get out and walk around, you will discover major forests, particularly of cedar, black pine or Pinus nigra, Austrian pine is its other name, and all of the lowland areas, so the great majority of Cypriot forests are down here, are Pinus brutia. How far can we go back from trees in Cyprus? Here am I standing next to and coring what is the oldest tree I know of on Cyprus, which I've kept secret from the Department of Forests. It's a minimum age of 872 years. That means it's older than that. There's a fire scar which I can't bridge across at the moment because it's unique. So the tree is more than 900 years old. And at the present moment, that is the oldest living tree. So to go more than 900 years back, you require wood from archaeological, historical, or other sites. That's a Pinus nigra tree, in case you're wondering. Thilo mentioned it was snowing in Cornell. This is not a photo of today, but it gives you an idea of what it's like in the winter. And this is my instant quick, how does dendrochronology work on an historical building? This is McGraw Hall at Cornell. It's on the Arts Quad. It's one of the 3 oldest buildings on the campus. And a couple of years ago, it was possible, on a snowy day, to go up into the roof space and take some samples there. And in particular, by identifying a few places, and this pointer is not going to point, nope. By identifying a few places where you actually have what's called bark edge. So we're on the part of the squared beam within the circle of an original tree where the people doing the carpentry have more or less cheated and taken the piece of the wood almost to the very edge of what was the original tree. So you can recognize what the Americans called the wane, English people call waney edge, and there's names of different things, but the ring below bark is there. So that is the cutting year, if you can date it. So we drill and take samples. In this case, we can test whether our answer is correct. So Costas likes forward models. This is a very simple forward model. We know the answer, and can we effectively get the right result? So we know that building started in 1868. There's a photo of the stone being laid. We know that buildings at that period in North America were built from the ground up. The roof was the last thing that went on, not like a modern thing where you frame it all out first. And we know that by 1873, it exists because it's there in a photo. So if the answer isn't somewhere between 1868 and 1873, dendrochronology does not work. So we look at our core that we took, and we took several. You can see the bark, it's blown, oh, there we go, it's working. You can see the bark blown up there, so that's the cutting date. You get the record of tree ring growth of the sample. You compare it against a master chronology of that species, which is hemlock, or eastern hemlock in North America. It's not the same, but you can see how the pattern significantly matches most of the ups and downs. For dendro, this is a very good fit, and because it fits over more than a century, it's a unique fit. And we get a felling date of 1870. It's got the complete ring. You can see it's got the complete ring. So it's cut down after summer growth. So probably it's cut down in maybe September or October. Probably it's then left out to dry until the following spring. So probably it's used in building work in 1871, maybe 1872. Building is up and running in 1873. It works. Or at least you've got to explain how can you offer an alternative. It seems to work perfectly. So this is what you're doing. Now, if you know the answer, of course, there's a limited interest in doing this. But in the case of most medieval and older buildings all over Europe, we don't actually know the answer. There may be a record of some date that a piece of land has been given by the church to some group. There may be some documentary record, but it rarely says when was the building actually built and finished. Or even if we know that, what about all the modifications and history that happened to the building afterwards? So dendrochronology offers the ability to date often the primary phase, but subsequent phases. So you've got the whole biography of a building or a group of buildings. So on Cyprus, I began work here many years ago, and some of you have been working here even longer than me, and others probably starting to regard me as one of the older members of the community. But dendro is becoming a brand new and exciting thing. And only last year, in fact, literally 12 months ago, more or less, we opened the Cypress Dendrochronology Laboratory, and we had a little event and a session, and here we are, and these are the approximate aims, and it's part of the APAC, or Andreas Peters Art Characterization Laboratories, which is directed by my colleague and dendro colleague, Nicholas Bakazis. So where have we been working? Well, starting at the recent and working back, we did the obvious. We thought, let's go and look at some fairly recent buildings because they're out there and it's going to be easy to find wood. So we first looked at some post-Byzantine or sort of even late Ottoman structures. And here are some of the examples of places that we were working and looking. So Isis Osmos, which is being excavated for the Bronze Age part by Despina Pelidou, and we were looking at the part of the abandoned village where there are plentiful examples of wood, and another village site, an abandoned village at Phoenikas, which is into the Parfos district. So these are the types of buildings that exist there. And these are the chronologies that we can build. So when you're looking at these bars against calendar time, this is where we have a tree ring record from timbers that we've collected or measured. And where they overlap and we're putting them together, we've cross-dated them. That means we've matched those growth patterns we saw before together, and I'm putting my professional reputation on the fact that these chronologies fit exactly here. And the big selling point for dendrochronology is it's an exact science. Nearly every aspect of dating, people mention errors, or somebody says something and then the question and answer, you put your hand up and they go, but I wasn't quite clear whether that was a 95% error or whatever. In dendrochronology, if you've cross-dated it, you're claiming that there is 0 error. The year shown is the absolute year, and you've actually, well, made a major mistake if that's not the case. Of course, there have been major mistakes. The German dendrochronology was revised by 41 years, only 20 years ago, and it was sort of one of those career ending/defining moments for some individuals. But in principle, it's an exact science. Apart from dating, these post-Byzantine ones that give a nice example, it's also a provenancing technique. So if your trees match together really, really well, that means they were probably growing in the same place. So the similarity of the growth patterns of a group of trees can basically map where they must come from. So if we look at the examples here from Isososmus, the size of the circle is telling you how similar they are to forest chronologies you have. And what this is basically telling you is most of the timbers are coming from very close to the Amientos mine area, which is not surprising. If you look at the map and consider distance, it's sort of probably the closest major forest area, so they're picking a convenient and economically viable resource. But this can be used in more complicated scenarios, for example, in Northern Europe. This is one of the ways of provenancing where ships are found in maritime excavations. How do you know whether it's a Dutch or a German or a French ship? Well, you can provenance or source where the wood was growing and came from and probably was used and built. This applies if you think about interesting cases. If you have an elite building somewhere which uses lots of wood, probably the person who's building an elite structure isn't so worried about cost. They're going to be more concerned about aesthetics or the implications and power effect of having like a cedar doorway or something special. So it's often going to be possible to see where have they had connections to. And in terms of art and objects, if you have an icon painter and they're working with timber that comes from a specific source or place, this may well tell you about their connections and source of inspiration other ways than just a question of where the wood came from. So this is at Phoenicas, and again you can see here sites over here in the Parfos district, and not surprisingly, the wood is coming from, broadly speaking, that surrounding zone and not from Amientos. So you can start to see how this allows you to place things in a regional perspective. And of course, one of the most amusing ones, which I won't put up, some of the most recent stuff at Isososmus, which is coming probably from buildings in the 1950s or 60s, in fact comes from southern Sweden. We refer to this as the IKEA phase. But globalization happened basically after World War II, which really starts to complicate the idea of traditional wood sourcing because things can come from locations that don't make sense in terms of a normal history. Okay, so working backwards a little bit further, there are a number of abandoned or currently not used, in this case falling apart, churches and other buildings, but still preserve wood, and we're able to match their tree ring records. So here you're looking at the red against the longer blue one that we've started to build, like from Isososmus, and you can actually, therefore, again, get specific dates for that. And as you can see here, we're getting a date in the earlier 19th century for this structure, which is just a little bit both north and slightly to the west of Hirakatir. Then we moved to more important historical buildings, having started to establish some chronologies and get some records together. So here we are at the Dragoman's house here in central Nicosia, which is obviously a major historical site and landmark, and started to work with some of the timber on the site there. And in principle, it's a case of looking around the site to try and identify where there are original primary timbers. Yes, there's been lots of reconstruction, and often when you show up at a building like this, the first thing the people in charge say, or others who've worked on it, in this case, Frosso came out to talk to us about it, is, oh, it's all been restored. Well, this is true. There's lots of restoration, but there are also lots of primary or secondary phase timbers here, which are not modern reconstructions at all. And in particular, here we were able to build a very long chronology of Pinus nigra, with the last ring so far at 1785. There is no bark yet that we found here, so you've got to add a couple of years between the last ring and the building. And oddly enough, that's pretty close to when we believe the building was constructed in its first phase. But the notable feature is, what's it matching against? It's matching against Pinus nigra from the Henistra, so High Troodos area. So probably indicative of the fact that this was the richest, most powerful person on the island in his period. This is timber coming from the top of the Troodos that's being at probably some considerable expense and effort as being brought all the way to Nicosia to build a high-status building in central Nicosia. So we learn something about the politics and economics of power here, as well as we start to be able to say that we can offer a date that in this case is consistent both with inscriptional and literary records. And obviously, it's a good moment and at the end to thank the Department of Antiquities for their active collaboration in this work. Beyond working with material from the Ottoman period, the real goal of the project, of course, was to work with material from the Byzantine phase because Cyprus has the greatest density of Byzantine heritage per square foot of anywhere in the world, and in terms of wooden cultural heritage of the Byzantine period, by far the greatest density of wooden cultural heritage per square foot or per square meter in the world. And although it's been studied extensively and in great and loving detail in terms of its art history, it has not been studied greatly or extensively in terms of its scientific component, and particularly in terms of dating other than in stylistic or art historical terms. And that's often fairly circular, meaning we believe a painting or a fresco looks like something else, therefore it becomes that date, and there's never any basis to how that date really came about in the first place. So, some examples of the sorts of things, and just highlighting to you that all of these structures are famous for being wooden roofed or part wooden built churches. So there's a considerable amount of wood if you can find primary or original wood. So here are some of the sites that we've already worked with, and pictures of various groups of Cyprus Institute students and others visiting us, group from this summer, group from a couple of years ago at Polendri, and what we're doing, ranging from trying to scan things in situ, through doing some coring with a special drill, through cutting some very small pieces, and some of the forests that we're then comparing it against. So we have, over the course of the last couple of years, built almost 250 years of a floating dendrochronology for the Byzantine period. Now when I say it's floating, that means it doesn't yet connect with a forest tree chronology. Once it connects with a forest and historical chronology, it will be placed to the year. That is why at the present moment it says relative years, and we just start arbitrarily at 1,000. But this already means that as soon as we can make this little bit linked to our forest chronology, we'll have about 800 years of continuous absolute record for Cyprus, which will date basically everything from the earlier Byzantine period, 13th century AD, onwards. And as you'll see in a second, we're getting extremely close. Where do you find wooden cultural heritage? That's important to not just think of the occasional big ceiling beam. There's all sorts of forms of wooden cultural heritage, both in these buildings, but also often now in museums and collections, ranging from random pieces of wood, which perform certain forms of architectural and engineering function, through to often lots of pine in the form of the iconostasis and the icons and other portable artwork that are within the churches, and things like bishops' thrones and many other features, and just the stalls that you sit in or stand in. Now, elsewhere in Europe, this type of portable art has been the subject, at least now, of about 30 or 40 years of attention. I'll just give an example here of a fairly undistinguished portrait of Elizabeth I. Its exciting feature, though, of course, is, and it's hard to see on the screen, but you can sort of see, this is an oak panel, and there are hundreds of rings running across this oak panel this way. Blown up here, one ring there, and then each of these big empty vessels is a spring period. The solid bit is late wood, the summer, so that plus that equals a whole year. So second, third year, fourth year, fifth year, and that's after 10 years. So that's 10 years of this oak chronology. Because it's such small, dense rings, even without measuring it, I can immediately state this must come from the Baltic region. So this is the so-called Baltic oak that was exported all over Northern Europe in its heyday period as the best and finest oak that a craftsman could work with. And because it's very small rings, it polishes beautifully in terms of being something for an artist to work with. You get no cracking on the artwork, and it polishes very finely. But in terms of dating, I measure that one, which equals this sequence. I compare it against one of the major Polish chronologies, and you can see it picks up all of the key features perfectly, such that I can happily say the last ring in that painting is AD 1495. And it's not 1495 plus or minus 3, it's not 1492, it's 1495. And because the complete ring's there, it means it was cut down after the summer of 1495, but before the growth started in spring 1496. So you can even start to get intra-annual information, which, when we move to the climate bit in a moment, can be very important. Do we have lots of art like this on Cyprus? Well, of course, the answer is more than one can deal with, realistically, in the sense of there's a huge amount of amazing wooden cultural heritage on Cyprus, and particularly artistic, ranging from, here we are in the Church of Ias Nikolaos in Zakistra, which has some really interesting works, through to perhaps not the most artistically prominent, but a church that in Paraclesia that was being conserved and worked on last year that we were able to measure. And here is an example of cleaning the back of the icon, where you can then see the ring pattern. And this is a group of the icons, and this is my co-PI in the project along with Nicholas Brita-Lorentzen here. Here are a series of icon panels, all different icons. Here are the saints being shown. But even with the naked eye and not being a dendro specialist, I think you can all see that these patterns look incredibly similar. They all have this big dip here and jump here. They all have this funny little sort of ski slope type period here. They all have this little period. So these are so similar, they must have been either the same tree or growing right next to each other. And by that I mean within a few hundred meters maximum of each other. This is coming from exactly the same little zone. So for this group of paintings, we can immediately say not only do they look as if maybe one or very few artists have done them all just on aesthetic grounds, but in terms of the materials, they'd be coming from exactly the same job lot of wood, which was all cut down more or less at the same time. So the impression that this was a quickly done set of icons for a church, we need icons, paint some, and have to be done by Christmas, or at least by, let's say, by next summer, you can more or less work out the nature of this artistic cycle by looking at the dendrochronology apart from the judgment made by the quality and otherwise of the painting. Can this be done apart from on a few movable icons? Well, examples here, occasionally it isn't good for the back, but you can actually try and clean and scan the bottom of doors and iconostasis doors. And one of the aspects of the lab here is we're trying to work on the strategy of taking the science to the site rather than bringing always the object to the laboratory. There's the possibility often of managing to get records even where you think you would not be able to. And here we're scanning another one within the church, and you can see here, by stitching together a series of scans, you can get an almost perfect tree ring record from, in this case, an icon. So Palendri is one of the churches that we've looked at and worked on a little bit, scanning an example up here. And you scan two parts of a door. They're not identical, of course, but you'll see that the pattern is basically the same. And in tree ring terms, this matches together and gives you a secure cross state between these two. Because one of the doors has a few more rings at one end and the other has a few more, you also now get the benefit of a longer chronology by putting the multiple things together. The longer the chronology, the more chance of matching it against other chronologies or forest records, etc. Chance to thank Satiri, who's in the audience here and was key in helping us work here at the Church of the Holy Cross. We've also been trying to push this as an educational initiative. It's not the point of the talk, but I just highlight the fact that with the Cypress Institute and also with my university, we've had a couple of events where we've brought students along with the idea of giving them both a cultural heritage lesson on the church and a technical lesson in which we've discussed how to do dendrochronology, show them how to do it, etc. So what date is this floating Byzantine chronology, and should people be getting interested in it? And the answer is, as of sort of like today, none of this has yet been published. This is in a sense brand new, and hopefully we will shortly be publishing it. We've done a couple of what are called radiocarbon wiggle matches on a few of these floating chronologies. So that means I have a chronology, but it doesn't yet match against the forest thing, but I do know that I have a ring 1 here, and I have a ring, say, 200 here. And if I then pick to measure ring 10, ring 50, ring 100, I know that there's exactly 40 years, say, between ring 10 and ring 50, or 50 years from ring 50 to 100. So if I take that specific time sequence, in which not only do I have a sample, but I know exactly how far in calendar time it is from all of its other ones, you can match that against the radiocarbon calibration curve and get a very precise answer that's almost absolute. So this is what we did. We measured 3 samples from one of the Palendri chronologies, and you can see that the radiocarbon ages match very specifically to one particular little location on the Northern Hemisphere radiocarbon calibration curve. So specifically that if you look, and I'll read it because I can't read the screen accurately from here, at 68% confidence, I'm saying it dates between 1527 and 1549. So we're placing this within basically plus or minus about 10 or 11 years. And this is only from 3. I mean, this was a first finder effort to try and see where we are. And where are we? Well, of course, this block of wood is sitting here, literally touching our longest historic forest chronology. So we need only a few more decades of wood, and this will match, and it'll be absolutely placed rather than almost absolutely placed. And then we come to perhaps the most exciting Byzantine site on the island, which I suspect is not one that most of you who live here in Nicosia have considered as a Byzantine monument until now, hopefully, which is Parfos Gate. And when I first thought about Parfos Gate, I was informed that it had been basically completely restored around about 1930, and therefore that was it. And then there was a devastating flood at the end of the 19th century, and if it hadn't been restored then, it had definitely been completely redone in the late 19th century. And it turns out that one timber, definitely, that one at the end, that is a 19th century timber that's been popped in there. But actually, on investigation and study, it turns out that most of the rest of them are not, in fact, 19th century. And here, what we've done is primarily we've sanded and made perfect little sections to get scans like this of the tops of some of the timbers. So the gate hasn't gone anywhere, we've gone to the gate. Most interesting thing is, although there's electricity here in the sense that there's lights, over several years we've become good friends with an Armenian butcher shop who've provided us with access to electricity to do this. So we should be acknowledging them as well. Well, here is the ring pattern from Parfos Gate, and this won't mean anything to you, but if you look across, Capan equals the church at Cordelli, San equals Ias Nicolaus at Sakistra. This Parfos Gate chronology matches extraordinarily well against our floating Byzantine chronology, and in fact at the earlier end of our Byzantine floating chronology. I then did the same wiggle matching thing because that seemed, well, interesting to the point that it's fair to say on first showing this type of diagram to a couple of people, particularly in the department, it was suggested that this was interesting, but was I sure? So of course one needs to be sure. So we did the same thing. We got some little samples which we knew were exactly 72 years apart. I measured the very same tree rings, if the cross-dating was correct, on the Cordelli church wood and on the Parfos Gate wood. Well, first of all, the two pairs of samples are incredibly close, so that's promising. And if you then fit them to the calibration curve, so that's the individual sites, and this is the weighted average of the two sites in the middle, there's only one place in the last 10,000 years they can possibly go, which is here. And that gives you a date for the last ring for the Parfos Gate sequence that we have so far, which is here, in the early 15th century, or earlier 15th century. Even this seemed to be not good enough. So we've measured two more samples just to be like over sure, which are two more from the Cordelli church, and again they fit uniquely here. We now have this shape. It's simply not possible that it goes anywhere else at all. And this leaves the last extant ring. We don't have bark at Parfos Gate, we only have little tiny almost outer rings, so that we might be missing a few rings, even a few decades at extremis, but not more. And it's placed, as you can see here, likely about 1427 to 1435. I would, of course, stress that's 68% confidence. At 95, it's 1423 to 1439. So plus or minus 8 years at 95.4% confidence, this is placed. And it's in the earlier 15th century, which really does start to be quite interesting because that means it's well before the date of the Venetian walls. So is this gate reused? Or was the gate already there as part of the pre-Venetian walls, of which there were? And we start to look at how the later walls incorporated this structure, which is the smallest gate. There's a number of anomalous features about Parfos Gate that start to perhaps make a rather interesting story as we think about this. So that's a major discovery, in the sense I think it's fair to say not too many people in the room would have volunteered, had they been asked randomly, do you think it's early 15th century wood a few years ago? It also means we can now more or less date the whole of our Byzantine floating chronology. So rather than just putting it up and saying it's a Byzantine floating chronology of nearly 250 years, you can apply these dates to that chronology, the same plus or minus 8. So we have a chronology now running, as you can see, from the early 14th century to the middle of the 16th century, plus or minus at 95.4% confidence, a total of 8 years. We will get it to 0 by matching it to the forest wood, but now already we know exactly the few decades we're looking for to do that. It's not a case of wondering what might work. We know exactly what we're looking for. We need to find wood that basically dates from about 1510 or 1500 through to about 1580, and then it will work for us. So if you happen to know of any key sites that were built around 1600 with 100-year-old timbers, please let me know. Pinus brutia particularly. So the state of the current dendrochronology is all of these are fixed. There's this tiny gap, and then we have this chronology which is floating, and we need to bridge it. So we're on the verge of having most of the last millennium chronology, which will date basically the Byzantine through Ottoman heritage, potentially, absolutely, and hopefully within a very short period of time. With Nicholas and Brita and a number of people in the room, we collected another nearly 90 samples in the last few weeks. We have hopes that some of those might prove to be promising in this regard. Okay, is it just buildings? No. Another thing that Cyprus, of course, is famous for is its underwater heritage. Now, this particular boat being shown here is from Israel, but I just do that to show you that all these boats so far and ships have tended to be dated on the basis of the ceramics. Of course, I love ceramics like any archaeologist, but there are lots of problems with dating things from ceramics, because often the date for the ceramics comes from a whole series of assumptions to which there's no really fixed endpoint. A whole series of stepwise logic transfers have been made that end up with a date at the far end from an assumption at the beginning. But ships also tend to have timber and other organic materials on them. So let's look at a famous ship here on Cyprus, the Mesotos wreck that Stella Domestica and team have been excavating for the last few years. At the time I got interested in the Mesotos shipwreck, it was about the time this was published, Stella will now say, but we've changed our mind a bit since, and it was dated as being primarily of the 3rd quarter of the 4th century. And we started getting some samples both of wood and of some of the olive seeds from the shipwreck to try and see if we could date it better. So the wood gave us a 47-year chronology, which we then did one of these same little wiggle matches on here. There's a little bit of random wood and a whole lot of olive seeds. And using a technique called Bayesian chronological modeling, in which you integrate this prior information, namely, I know the ring sequence of the dendro sequence. I know that these seeds are all coming from the same last voyage of the ship because they're in the storage jars. One expects this to be after that, and one expects that order to be present. So given those several constraints, you can expect to get quite a precise chronological outcome, because like any simultaneous equation, if you have multiple parameters to solve them all at the same time, you end up usually with a fairly unique solution, if not a unique one. So the last timber dates here at the very end of the 5th century BC, and there's a terminus post quem on that because at the present moment there's no bark on this timber, so it's after that date, so after the last couple of decades of the 5th century BC. And the short-lived material is giving you I've got it last voyage, so LV date, which you can see is 388 to about 377. Again, I would highlight the fact that's like 11 years. So it's fairly precise and dramatically so, but it's also not the date that we had from the ceramics. Can this date be made better? Of course. Is it more or less absolute? Well, the answer also is yes, because here's the calibration curve, very specific shape. That wood fits on this little plateau, the seeds fit on the steep slope, and there's nowhere else in the last 10,000 years that possibly could apply. That shape is unique, and it's quite dramatic. This is the so-called, for European prehistorians, this is the Hallstatt Plateau, the supposedly end of the Iron Age resolutional. That's starting to change. So this change that happens around 400 BC is incredibly clear. So by luck, the Mesotos shipwreck fits in that one and only place that you have a unique fit potentially. That's the date we're getting. That's where the ceramics was getting it. So is the so what question? Well, the so what question is a change of about 50 years, which is significant, clearly. That's quite large enough to be important in terms of historical context. And it will undoubtedly lead to a rethinking of some of the ceramic chronologies that led to the first date and will become a fixed point in future ceramic work. And this morning, with Stella and Eleni Loizou, we in fact have been working on some of the new timbers that came from the 2019 season, And the hope is that that's going to enable us to extend, because this timber here has maybe 90 rings versus the 47. Hopefully that's going to make this fit on this plateau absolutely secure, and aiming at like plus or minus less than 5 years for this. So it will become the best dated Iron Age shipwreck in the East Mediterranean, in fact in the Mediterranean as a whole. Then the last part of what we've been doing, and which links with other work here at the Cypress Institute, is to look at climate from tree rings, because I've said that trees in the same area, growing in the same conditions, reflecting the local climate environment, have similar ring patterns. Well, of course, you can then invert that and say, well, if you understand what the conditions are that create the weather patterns that equal those tree rings, if you measure that tree ring pattern and you can look at that pattern, you should be able to work back and say, well, what was the climate conditions that created big rings and small rings in the past? So, for example, using Pinus brutia trees here from Cyprus a couple of years ago, we published this 250-year drought reconstruction, in which we looked at the record from the recent period where there's instrumental information on rainfall at several rainfall stations, and Cyprus Meteorological Service has this and provided it, and we can calibrate our measurements against that and show we can correlate them with very good probability, and then you extrapolate backwards. And it's hard to see, but back to here, we're comparing extrapolated versus the instrumental, and then we take the fudge factor from that period and go backwards. The statistician can, of course, say, well, how reliable is that? And one says, well, it explains, like 55% of the variance and so on. So it's never perfect, but this is the standard way of trying to get an estimation of past climate. And because you have a lot of trees involved, we have a couple of hundred involved here, it starts to be pretty robust. So what do we determine, for example? Well, each of the stars are marking the major dips in the record. So these are severe drought episodes. And we started this project in 2008 where there was a major drought on Cyprus. And there seemed to be a general feeling that droughts seem to be happening all the time on Cyprus. And it's getting worse and worse. Now, obviously, you've only got to read the newspaper / internet / anything to know clearly it's getting hotter and drier generally as a pattern. But of course, it's not a smooth curve. It's a pattern that goes like this. So one of the questions is, what type of cycle do you get these major drought episodes in? And what we're discovering here is they happen regularly, but not all the time. They're happening at spacings of a couple of decades to a few decades. So these are written out to give you some idea of the type of timing. So some you'll recognize as historically important. I mean, 1901 is where you read accounts about how many Cypriots left the island, for example. So these are historically forcing events, but they happen periodically. 1973, obviously, is one that affects the entire East Mediterranean. Some of the trees live much longer than the Pinus brutia trees and give potential to do multi-century, even almost millennial records. Cedar trees in particular, there's a little area of cedar forest in western Cyprus, and a couple of trees, including this guy here. This tree is just over 600 years old, so it gives you a very long record to work with. So you measure all of your trees, you do various forms of statistics to get a record out of this. You say it's solid because I put 77 trees into my record. I'm getting a Pearson correlation of 0.61, which is sort of about twice what people in the dendro field would regard as solid. And I've got most trees contributing at least 200 plus years to the chronology. So I have very long-lived trees, so it's a very stable record. So from that, you can hopefully start to say something rather exciting about climate, but also history and events. And I've gone with the history and events as an example here. By looking at the record of fire in the Cedar record, it tells us about how humans are using the environment. And it's very interesting that you'll see that up until the 17th century, well, for quite a long period, there was no major fire in this whole area. And since the late 17th century, there have been periodic regular fires in this area. And of course, this tells us about changes in the use of landscape. It tells us about grazing going into the forest. This little period here starts to tell us about when the British started their whole change of the nature of forest management, which had some success perhaps. But not only can we look at just raw climate, like trying to reconstruct rainfall or drought, but we can also reconstruct human-environment interaction. So if you're a theoretical archaeologist and you're into materiality and citing Ian Hodder and so on, this is a way of actually looking at our relations as humans with our material world and vice versa in terms of how we've shaped it and it has shaped us through use of tree rings, but with precise dates. Another example that we've worked on looking at central Anatolia. We can do the same thing with a couple of different records, one from southwest Anatolia, one from the North Aegean, so North Greece and parts of Anatolia. This is looking at precipitation reconstruction for the last 1,000 years, basically. Each of the stars represents a year in which the rainfall was more than 2 standard deviations lower than the average. So it's an arbitrary statement, but a year that it's more than 2 standard deviations, so it's outside of the 95% range, it's going to have been really dry. How often does that happen? Well, you can see from this diagram from 1100 to 1600, only a couple of times, and at no occasion are the stars right next to each other. If we look at the period from 2000 back to 1600, you'll see the same. Star, a couple, they're almost close together, a couple, but not very many. And in the record at the top, you can see more or less the same, although there is that one and this one, so there's maybe one exception. And if we put that all together and consider those records, it's only twice in the last millennium that there's been 2 years in a row when we've had a really, really, really severe drought, which has affected most of Anatolia, so both north and south. One is in the early 20th century, 1927, 1928, and if you read your Turkish history, you'll see that that was a huge crisis under the Ataturk regime. But modern world, I mean, they had telegraph, they had trucks, they had planes, they had ships, they coped. It made a big dent in GDP, but they coped. The previous one, which is probably much more interesting, is this one here at the very beginning of the 17th century, which affected the whole region. Was this historically forcing? Well, as Sam White has argued, the Jalali Rebellion, which just about brought the Ottoman Empire down, occurred and seems to have been largely driven by this climate event. And now that everyone has decided that we're in a climate crisis, climate something, this is the type of event which gives a parallel for what happens when you have a major empire faced by a climate crisis which they can't cope with. Because if you're a traditional society, how did you cope with climate change and environmental change? Well, you tend to try and store enough food and seed to last through one bad year. And whether you cite people like Paul Halstead or Hamish Forbes or others, this idea, the grandfather of the theory was you always allowed for one bad year, you could ride it out. And maybe even if you had with your olive oil and your animals, maybe a second one. But studies of all medieval kingdoms show that they really couldn't cope with anything that went beyond a second year. That exhausted their technology. The storage didn't work beyond that. Grain oxidized and went off. You couldn't do it. So if you have a crisis for 1 year, despite the fact in my little graph when I had little stars saying every 10 to 40 years, people die, it's a crisis, but the society survives. Once you get 2 in a row, you're on the verge of actually defeating most human adaptations until the very modern period with air conditioning, freezers, global exchange. And even then, it's a challenge. So this episode perhaps is the historically forcing one of the last 1,000 years we need to look at very closely, including obviously on Cyprus. And working backwards, this is the type of thing we can use tree rings for to try and understand what is the connection between climate change and actual historical and societally forcing change. Not just trying to find hot or dry years, but the ones where civilizations collapsed or almost collapsed. And because it's from trees, and because trees have locations, you can even map where this type of drought is occurring in terms of geography, GIS obviously, but it's not a case of just saying, oh, it was in Turkey, or oh, it was in Cyprus. You can more or less quite precisely indicate which regions were most affected. And of course, when it turns out to be the Konya Plain area, and it turns out to be a breadbasket, where was, of course, the Jalali Rebellion centered? Konya Plain, oddly enough. So you can start to see the link between history and climate. Is this only applicable in the recent period? Well, no. If we look at a long chronology that I have from late prehistory, so coming around the period at the end of the late Bronze Age, so that's around 1200 BC, here we have a really interesting situation where 19 of 23 years, just as you can see around 1200, are really unusually dry in central Anatolia. This is the time the Hittite Empire hits problems. The entire East Mediterranean, all of the polities hit problems. Most of the major sites on Cyprus, particularly the coastal ones, are abandoned. Do you just look at the ring pattern? No. One of the key measures of what's going on in a tree is its moisture uptake, and you can monitor that using stable isotopes. That means things like carbon-13. So carbon-14 equals radiocarbon. It's radio because it's not stable. I hold my lump for 80 years, 1% of it vanishes. Carbon-12 and carbon-13 are stable isotopes. They don't go anywhere, whether you hit them with a hammer or whatever. But the amount of the ratio of carbon-13 in a plant is telling you about its way it's taken up moisture, particularly through the stomata and the leaves. So as the values go up in this little diagram showing stable carbon record from this chronology here, this is getting drier and drier. So we can not only just say, oh, it's interesting, it's going to be low growth for 19 or 23 years, we can actually quantify and explain that on average it is getting drier and drier in this period leading to the end of the 13th century, which isn't just a case of saying it's drier, but it's also very precisely placed. Other people have suggested from pollen and other records there may be a drought here, but typically plus or minus often 50 or hundreds of years. This is plus or minus just a handful of years. And a final example, there's been years and years of debate about a so-called 4.2 event, so that means 4,200 years ago, or about 2,200 BC. Harvey Weiss in particular has built his entire recent career on the concept of this great event which was epoch-changing in terms of the history of the ancient Near East. Here we actually have now a 600-year chronology that was built from Katna, thanks to Peter Fowsden's work in northern Syria, obviously before the war, in which we put together all of these timbers. We've wiggle matched the chronology, and you can see it fits between here, the beginning of the 23rd century BC through to the earlier 17th century BC, plus or minus about 9. And again, we started doing stable isotope work on this. This is going to be a way of understanding, did the early Bronze Age, so-called early Bronze fall, was this a period of dramatic climate change? We know that we have rulers like Shamshid-Adi who then become kings in the early Middle Bronze Age. Supposedly their ancestors had been shepherds and they'd been mobile, and it's only at the beginning of the Middle Bronze Age we see sedentary life again. We have a tradition of what's meant to have happened, but this starts to give us the possibility of having hard concrete science information which tells us what was the nature of the climate and environment at that time, and how did that link to the history and culture that we've been told about. So thank you very much for listening. Questions?
Thank you, sir. Yes, would you mind a few questions?
No, go for it.
So thank you very much for this very insightful overview of what dendrochronology can actually do. We have time for a few questions from the audience.
Of course, I should say thank you, obviously, amongst many others, to all of these people.
Yes, Ercan.
Thank you for this beautiful talk. Really, I appreciate it. You have a beautiful time series. Have you ever considered taking a Fourier transform of that?
Did people hear, or you want to repeat the question?
Maybe I just repeat. You have beautiful time series, and if you take a Fourier transform of it, you might get some frequency information which may have some other features.
Okay, in the climate part, this is exactly what people do. So you're trying to remove noise to get signal. People do use Fourier transform. A lot of people typically use other types of spectral analysis, so you're trying to find the periodicity in which certain things happen. So for example, I know if I do it on my Gordian series, I get something around about 11 years. Guess what? That's going to be the solar cycle for sure. So certain things predictably show up in every record, but don't necessarily really inform you of something, whereas there's a record that Ed Cook has been working on in Central Asia that shows an apparent drought periodicity in a couple of century range, and yes, he's been doing exactly the type of thing you're referring to, and absolutely. And that's the way also of quantifying, in a sense, what we don't know, meaning the reconstruction, the next step is, of course, to try and quantify how certain you can be of that, and it's the same thing. What are the parameters?
Thanks.
Using isotopic analysis of each of the rings, you may be able, or presumably you have already, identify content of the atmosphere or certain, either from volcanic events or other incidents in the climate of the planet. Is this now being pursued with the refined isotopic analysis that it has become available?
Okay. So that's both fascinating and more complicated than it seems. And I've been trying to do that since the late 1990s in terms of the volcanoes. Certain things like radiocarbon and carbon-13, which come in, they effectively, from photosynthesis, they are fixed in the cellulose of the wood of the year it's growing. So there you are directly measuring. So if we're looking at ring 1600 and we analyze the carbon-13, we are getting 1600. If it's actually the very good start of the spring growth and it's a deciduous tree like Northern European oak, it does actually include a fraction of the previous year. But you're very, very close. But for things like volcanic fallout, there's the reservoir issue, because of course it rains down, it goes into the soil, and then it's how long it takes from a soil reservoir to come up into the tree. Many areas of the world, so let's just pick Germany or England or somewhere where you have your classic sort of forests of deciduous sort, that's often 20 years because you have these clay soils and so on. There's a big lag. We tried, and we used bristlecone pine as one of our things in an early experiment. You find a tree that's growing on basically a completely soil-free, steep, rocky hillside where, of course, you can't understand how anything's growing at all. Therefore, you hope that most of what's in the tree must have come in through the leaves and the bark because there's no reservoir sitting there. And 2009, we tried, and a paper in Journal of Geophysical Research, we put a lot of effort in and we did some synchrotron work. We did other stuff using ICP-MS laser ablation. We found some hafnium, which was really interesting, but moderate success. So we've had some success. We found Tambura fairly confident. We published that in Journal of Archaeological Science some years ago. But the further you go back, the problem is, of course, not only do you then have all the thing I've just told you about the reservoir, but if the wood is now no longer in a tree growing, it's often going to have started to absorb things from its secondary deposit. Has it been sitting in a river? Has it been sitting in the soil? Has it been just sitting in a historical building being sprayed by people with creosote or something? And actually trying to get samples that work as you go back gets harder and harder and harder. So definitely we're still working on it, but it's not as simple as it seems in terms of anything that's in the cellulose. Cellulose is a wonderful thing in which if you can go down to alpha cellulose, really there's very few things that cause problems. Anything less than that, you have lots of things that can cause problems.
Thank you for this lecture, and really I enjoyed it. Talking about fire events and dry seasons, have you find any correlation between them?
Between events and dry seasons.
Fire and dry.
Okay, so the example from the Hittite, I won't scroll back. Yes, there we have, everybody knows there's meant to be some sort of crisis at the end of the Late Bronze Age. Some have seen it as being political, some have argued for a number of different causes. The fact there seems to be a century-scale trend in aridity rather than like one event, that may well be very historically forcing because each year it's not a crisis, but at some point it reaches a tipping point. It's got worse and worse and worse, and now it's not really viable. The crops are insufficiently good in central Anatolia maybe to feed all the people that the Hittites rely on their tax base to give them the resources from. And that type of bottom failure is going to feed its way up through the system, and eventually the elite are affected because their system, their invariably tax system, is not going to sustain what they're trying to sustain. So that type of idea is definitely in play, and there have been a number of studies trying to develop that and work with that sort of concept. And very specifically, yes, we can identify particular events where we can see a dramatic drought, and it either matches against an historical record of famine or otherwise. I mean, I was talking about somebody this earlier today, the 4th century AD, and the account of Basil is one where we can find records which give us clear evidence there was some sort of drought. But it's a nice one because you have a political bishop who's also making a lot of it. So, of course, even though people may be dying, there are opportunities in such crises for politicians and others as well. So it's always complicated. I mean, it's not a simple human thing where A equals B. As Amartya Sen famously says, people don't die of famines in democracies. It's sort of true. But dictatorships or otherwise, of course, these can provide either evil or good opportunities to change things using that crisis as a pretext. I mean, early 20th century and what happened in Ukraine and parts of Russia is a perfect example of how 1921 was led to T.S. Eliot writing The Wasteland, because it was very dry. Dry has been in the last several hundred years in England. But he wrote a poem, Other parts of Europe, millions were dying of famine because the government chose to have other priorities.
Okay,
Well, up to you.
Thank you very much for this nice informative talk. I would like to ask you whether there is a good fit between the chronologies that we are building in Cyprus with the chronologies of the Dendrochronological project, which was running by Cornell.
The answer is yes and no. Yes in the sense of yes, we can match certain things together, but no, because the previous work done, so basically Peter Kammerholm, he did a teeny bit in Cyprus, but for his own reasons of preference and interest, he concentrated primarily elsewhere, i.e. Turkey and parts of Greece. So he'd never collected from nearly any of the places we've been. And even within Greece, I'm finding places he didn't. And in Turkey, and I was in Kultepe only a month ago collecting samples. Again, different people have different interests, and I'm quite sure in X decades, somebody will be standing here or on a new version going, I don't know why Manning didn't look at this. I mean, that's inevitable. You never can do 100%. And the theory and reason you're doing is changing. I'm interested in climate. He wasn't. I'm interested in this link between the art and politics. He wasn't. Portable art, he simply had no interest in doing icons and things. We're being interested. So every generation does different things. But do some of my long chronologies here match against other places? Of course they do. So for example, if we get several hundred years here from lowland pine, so Pinus brutia, they typically will match against some records that are coming from Israel, because the macro record of the dry areas is quite similar. Were I working in parts of Syria, which I am not obviously at the moment, the same applies, certainly on some of the historic ones. And then other ones don't. So for example, cedar trees in Western Cyprus are unique. It's a unique environment. They match against nothing else. The pine trees at the top of Drought do correlate quite well against pine trees also growing at about 2,000 meters in southwest Turkey. Because again, it's a similar macro environment. So that's why I say yes and no.
There are also oak trees in Cyprus or not? Oak trees. Yeah.
Very few, and those that are, so the big oak, I mean there's lots of different oaks. There are deciduous oaks, as in what the Tower of London's built of and so on, and there are evergreen oaks. Evergreen oaks are very hard, they don't produce proper rings, they're nasty, you don't go near them if you're a dendrochronologist if possible. Deciduous oaks are wonderful when you find them, and maybe like a ship, so the Nishar ship, for example, has oak, which has probably come from Northern Europe. So it's relevant to dating Cypriot material, but it didn't grow in Cyprus. And when you find oak, which you do occasionally in buildings here, it's probably come as part of Ottoman timber trade. So we know from documentary records, the Ottomans were selling timber, for example, to the Mamluks in Egypt. So wood that never grew anywhere near Egypt can be found in a building in Egypt because of a trade. And one project we've worked on is a couple of shipwrecks off the coast of Israel, where we can very much demonstrate that the wood the ship is built in probably comes from the Black Sea, and there's a whole complicated biography as to how it ended up somewhere off the a siege of Akko.
Thank you very much.
Thank you again very much.
My pleasure. I'll sit down.
Now, we have heard a lot about trees standing for hundreds of years and witnessing a lot of what happens around them without moving, without going anywhere, but preserving and building things and are very constructive material. And I want to spin that picture a little bit further and invite my president to the podium to say a few words now. Before then, we have a reception afterwards. Kostas.
First, I would like to thank Sturt for this stimulating, wonderful injection of lots of energy, ideas, problems, climate, chronology. Thank you very much. It's a feast. But as most of you know, this ICAS M2 conference this year is dedicated to the 90th birthday of Professor Karagiorgis, and we don't need the chronology there to mark every year of his contribution to the history of archaeology in Cyprus and the region. We don't need 3 rings his publications year after year, and there is one that came out 2 weeks ago, mark clearly his impact on the archaeology, the history of the development of this field in Cyprus. It's a real pleasure to have Vassos with us. It's an honor, great pleasure to have him since the beginning of the Cyprus Institute, injecting all these fantastic questions. I remember when it was still an idea, I visited him at his office at the Leventis Foundation, and he said, dating and provenance, use scientific methods. This is what the region needs. It's happening, Vaso. It's happening. Thank you very much. The Cyprus Institute is very pleased to join this celebration in honor of Vassos. We have this reception in his honor. I will stop here and invite everybody to the reception to raise our glasses to the many more coming achievements of Vassos, which every year that passes without a ring will be added to the voluminous work of his. Thank you very much.
I feel very embarrassed hearing all these encomia since this morning, encomia which I do not deserve. But I suppose, Mr. President, dear Kostas, and Professor Reren, dear Thilo, this is your way of saying goodbye, or more accurately, farewell to a colleague who, at the age of 90, retired from his fourth post. I will not seek another one. The message which Professor Thilo Reren sent me on the 1st of November, announcing to me the decision to dedicate your Congress to mark my 90th anniversary, came to me as a surprise, considering the fact that I am an illiterate in matters of your specialization. Like a number of other archaeologists of my generation, who have been brought up with the idea that archaeology differed little from the history of art. Having to deal with Cypriot archaeology, however, and facing the attitude of most classical scholars of the older generation, I consider you, Sturt, as a classical scholar of the younger generation, was hearing that Cypriot art was provincial and therefore insignificant. I soon realized that the task of an archaeologist is to investigate all aspects of human life and all the materials associated with it, irrespective of their aesthetic value. Some people of my generation took refuge to the easy and novel methods of theoretical archaeology, very often confusing the mission of the archaeologist with that of the historian. By saying this, I do not mean that the archaeologist should be dissociated from historical investigations, but there are borders to be respected. It became my conviction that everything material discovered in an excavation should be thoroughly studied and understood, whether this was a piece of charcoal, a piece of bone, a lump of copper slag, an eggshell, or a seashell. The publications of my excavations at Salamis in the 70s are full of appendices written by specialists. The creation of the Cyprus Institute with its star C came as a godsend gift to Cypriot archaeologists, and I became one of its staunch supporters. I suppose this is what made you decide to honor me now that I have reached the twilight of my archaeological career. I wish you every success in your research and many more conquests of scientific peaks. Thank you.
So, with that, the official program of the day is over. And on behalf of the Cyprus Institute, and thanks to the generosity of Kostas Papanikolas, our president, I invite everybody to the reception outside.